China says it may have solved a mystery on the moon's surface. Ferric iron was assumed to be rare on the moon, but samples returned by China's Chang'e 5 mission suggest it may really be abundant, according to Becky Ferreira on Vice.com. Scientists may have solved a long-standing puzzle about the origins of a mysterious element on the moon with the help of lunar samples that were returned to Earth by a Chinese mission in 2020, report of a new study says. China's Chang'e 5 mission wowed the world 2 years ago when it became the first spacecraft in decades to land on the moon, collect samples, and safely deliver them back to Earth. The probe was able to scoop up about 1,700 grams of lunar dirt from an unexplored region that was volcanically active within the past 2 billion years, making it one of the youngest parts of the moon's surface. The pristine extraterrestrial pebbles contained globules of ferric iron, Fe3+, a version of iron that contains oxygen, which was previously assumed to be rare on the moon because the lunar surface is chemically reductive, meaning that it's not easy for oxidized compounds to form. Now scientists led by Haiyang Xian, a geochemist at the Chinese Academy of Sciences, Guangzhou, demonstrate that this compound can be forged by tiny rocks called micrometeorites that constantly pelt the lunar terrain. The discovery reveals a dominant pathway for the formation of Fe3+ on the lunar surface and suggests that much more ferric iron could be present on the moon than previously thought, and that its abundance is progressively increasing with micrometeoroid impacts, according to a study published on Monday in Nature Astronomy. The occurrence of Fe3+ in lunar materials has been discussed for decades. Xian and his colleagues said in the study how Fe3 forms, accumulates, and evolves in the reductive environment of the moon's surface is still under debate. Here we present robust evidence from a lunar sample labeled SC5CO and all those numbers for the formation of a large amount of lunar Fe3 made by chemical reactions during micrometeoroid impacts on the airless lunar surface, the team said. The mystery of the moon Fe3 dates back to Apollo era, when NASA astronauts hauled enormous loads of rocks back from the lunar surface. At that time, Fe3 was only faintly detected in these rocks, but more recent analysis with better instruments have revealed higher than expected concentrations of the oxidized compound in the Apollo samples. Moreover, a recent orbital study of the moon found high concentrations of hematite, a rusty iron oxide, at the poles, a finding that has also perplexed scientists. It's possible that these iron compounds are getting their oxygen from Earth, as our planet does leak its atmospheric gas into space, or from lunar ice deposits. However, these explanations don't fully account for new findings about the moon's Fe3 content. Xian and his colleagues think they may have finally solved this riddle by meticulously examining Fe3 particles that are suspended in glass shards called agglutinates from Chang'e 5 samples. The team suggests that the ferric iron in the samples were created by a so-called charge disproportionation reaction that occurs during micrometeorite impacts. Unlike Earth, the moon has no atmosphere to protect it from micrometeorite impacts, leaving its whole surface exposed to a ceaseless rain of space pebbles. These impacts may help explain how oxidized compounds form on the moon and could also suggest that Fe3 is far more abundant on the lunar surface and perhaps similar worlds than once imagined. Importantly, the large amount of Fe3 in the agglutinate glass produced by charge disproportionation may enhance our knowledge of the evolution and distribution of oxidized iron compounds on the moon, the researcher said. The widespread agglutinate fragments in the lunar regolith and ongoing micrometeoroid impacts suggest Fe3 could be a universal component with increasing abundance on the moon. And this is on Vice.com by Becky Ferreira. Please leave your comments. Thank you for your support. Kindly support my Patreon account The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box